Welcome to my presentation on AffordPose, a large-scale dataset of hand-object interactions with affordance-driven hand pose. This work is a collaboration between Dalian University of Technology, Shandong University, Shenzhen University, and Tsinghua University. Object usage plays an important role in a functional hand-object interaction task. The agent needs to understand what interaction to perform, where to interact with the object, and how to perform the interaction to achieve the purpose. Most previous datasets only consider the general grasping task and focus on the stability of the generated hand poses, but overlook the object usage and semantic meaning of the interactions. In cases where object usage is considered, it's often categorized into two types in the relevant works. One is human objectives, such as use, and handout, but they are general goals and take the objects as just geometric shapes rather than functional objects. The other is object-centric affordances, but they with a limited generalization ability. We present the AffordPose dataset, a large-scale dataset of fine-grained hand-object interactions with affordance-driven hand pose. We first collect the specific part-level affordances on the objects, that's the hand-centered labels such as twist, wrap grasp, handle grasp, and the corresponding parts. And then we manually adapt the hand poses to complete the interaction tasks corresponding to these affordances by simulation software. Our AffordPose dataset records the complete hand-object interaction information, including the 3D object shape, the part-level affordance labels to localize the interaction, and the hand pose parameters to complete the interaction task. In this table, we statistics the data in the AffordPose, which collects a total of about 26.7K affordance-driven hand-object interactions, involving 641 3D objects from 13 different categories and 8 types of affordance. In this part, we provide the following data analysis to understand how affordance affects the detailed arrangements of hand-object interactions, including showing the per-affordance representative hands. What representative hand is defined as the nearest hand model of the mean intrinsic parameters for a specific affordance. Sampling the hand-object interactions on the same mug to reflect the distinctiveness of affordance-driven hand poses. Showing one affordance often leads to similar joint configurations for the interactions with several different object categories. And showing the hand-object interactions of the same affordance also exhibit a degree of diversity. We also provide quantitative data analysis to show how affordance affects the contacting and configuration of the hands. In Figure 1, we compute the contacting frequency of the fingers for each affordance label to understand the importance of the fingers when performing different actions. In Figure 2, we specially select the two affordance labels to further quantify the standard deviation of each hand joint angle, to understand the detailed diversity of each affordance. Next, we conducted experiments on 3 related tasks using our AffordPose dataset. Task 1, Hand-Object Affordance Understanding. We conduct multiple experiments with different input and output settings to infer the affordance labels from a rough hand demonstration and a target object. Task 2, Affordance-Oriented Interaction Generation. The task aims to predict a possible hand pose from the input object and a given affordance label. We compare the generation ability of the original GrabNet baseline and our variant named AffordPoseNet. It is worth mentioning that we add more than 200 objects with part-level affordance but no hand poses annotations to expand the test set. Task 3, Image-Based Applications. We rendered the RGB images of the hand-object interactions from the AffordPose dataset and conducted an RGB-based hand-object interaction understanding and mesh recovery experiments. Thank you for your listening.